Hi everyone, this is the second video of 1B.5, and in this video we are going to be multiplying and dividing rational expressions. I'm going to start with a quick reminder of how to multiply and divide regular old fractions, and then we'll dive right into a couple of examples of multiplying and dividing rational expressions. So when you multiply fractions, you multiply the top numbers and you multiply the bottom numbers. Anything that was on the top, you keep on the top. Anything that was on the bottom, you keep on the bottom. So this just turns into 3 times 5 over 7 times 2. So basically, I could have just created one big fraction out of that multiplication, and I end up with 15 over 14. Done. So multiplying, whatever's on top stays on top. So if I went down to do one of these examples, when I multiply across. 5 times 4 is 20. I can only multiply variables. So I can't really do anything with the exponents since x, y, a, and b are all different. So I would just write x squared, y to the fourth, a squared, b to the fourth. On the bottom, I've got 2 times 10 is 20. A, b to the third, x, y to the fourth. So at this point, once I multiply across, I simplify. So 20 over 20 is just 1, so I can get rid of those 20s. Let's see, y's are going to cancel because I've got 4 on the top and 4 on the bottom. Now, one strategy that I use, and I used this in my last video, is wherever the value is going to end up, I circle that. So x squared over x, there's more in the top than the bottom, so x is going to be left on the top, but it's going to cancel this one, and there's going to be 1 left because there's 2 on top, 1 on bottom. 1 cancels out, 1 left over. Next, I've got a squared over a, so that's going to be left on the top with 1, and this is going to go away. And then b to the fourth over b to the third, there's going to be 1 left on top, and b to the third will go away. So I had 1 x left on top, 1 a left on top, and 1 b left on top. So there is my final answer. Now, when you do this with polynomials, remember in the last video, you have to factor everything before going. So this first one, x squared minus 49, is a difference of squares. It's going to be x plus 7, x minus 7. On the bottom here, 8x minus 24, all I can do is take out a GCF of 8. So it'll be 8 times x minus 3. In the top over here, I've got x squared minus 3x. All I can do is take out a GCF of x. So I've got x times x minus 3. In the bottom, I've got a trinomial. Now, a lot of people like to go off to the side with a trinomial and factor it, so I'll do that here. So I've got x squared plus 3x minus 28. Remember, a trinomial, I go triangle up, negative 28. And that's going to be 4 times 7. So the 7 will be positive and the 4 will be negative. So I've got x times x plus 7 minus 4 times x plus 7. So that'll end up as x plus 7 times x minus 4. So I'm going to put that in place of that trinomial. Now at this point, everything on the top would stay on the top, everything on the bottom would stay on the bottom. So I can go ahead and anything I see on the top, I can cancel out with anything on the bottom because those are those like factors that are top and bottom. Because what would happen here is this would create one big fraction, this times this times this. Everything's being multiplied, so I get rid of those common factors. So if I divide by x minus 3 top and bottom, this goes away. And if I divide by x plus 7 top and bottom, this goes away. So now what I'm left with is x and x minus 7 on the top and 8 and x minus 4 on the bottom. So I'm just going to write that so it looks nice. So x times x minus 7 over 8 times x minus 4, and nothing can be simplified from there. There's no common factors left. So there it is. So your steps are factor every part, cross off or divide by common factors that are on the top and the bottom, and then write what's left. So now at this point, I'm going to do an example of division. Division is a little bit different. There's one added step here. So in division, you don't just multiply across, you don't divide across. And when you divide by a fraction, you multiply by its reciprocal. So that might be a note you want to write down. Multiply by the reciprocal. So instead of 11 over 4 divided by 3 over 7, you have 11 over 4 times 7 over 3. Now I've created a multiplication problem, so now I can do exactly what I did in the last couple problems. So now I've got 11 times 7 is 77 over 4 times 3 is 12. So basically, any division problem you turn into a multiplication problem and go from there. So I'll do one division problem on that. Let's go with number 14. So number 14, I'm going to factor everything, but first I'm going to switch this. So I always circle the division sign and draw arrows like this. So I'll rewrite this, x squared minus 8x plus 15 over x squared minus 25, that stays. And then this turns into x plus 5 over x squared minus 9. So now I have to factor everything. I have to factor this one first. So x squared minus 8x plus 5 multiply plus 15. I get 15, so I'm going to split this into negative 3x minus 5x. Take out x, take out negative 5. I get x times x minus 3 minus 5 times x minus 3. So I can see that my factors are going to be x minus 5 times x minus 3. On the bottom, I have a difference of squares. X squared minus 25 is x plus 5, x minus 5. Then x plus 5 I can't factor, so I just leave it there. X squared minus 9 is another difference of squares. So that's x plus 3, x minus 3. And once I've factored everything, now I'm just on the hunt for what matches. So I see an x minus 5 in the top here and an x minus 5 in the bottom here. So I divide by x minus 5 top and bottom to get rid of that. I see an x plus 5 here and here. Divide by x plus 5 top and bottom. And lastly, I see an x minus 3 top and bottom here. Notice nothing is left in the top. When nothing is left in the numerator, or in either case, when nothing is left, I have a 1 on the top. 1 over, the only thing left is x plus 3. In this case, it's really important that you leave the 1 there, because otherwise it just looks like x plus 3 over 1. You need to make sure if there's nothing left in the numerator, you leave 1 in the numerator. So quick recap. Anytime you're multiplying or dividing, you're always factoring everything you see. If you're multiplying, everything that was on the top stays on the top and you just multiply across, and then you can cancel factors as you see them. When you're dividing, you multiply by the reciprocal. So the second fraction, whatever you're dividing by, gets flipped. So I like to circle the division sign, flip the second one. So that's multiplying by the reciprocal.